Hey guys, hope you're doing well. I thought I would talk about day one lesson a little bit and give you guys a few tips. On the do now, number one, I hope you noticed that the median is the point with 50% of the data below it and 50% of the data above it. And that hopefully felt kind of easy. Likewise, on number two, I hope you noticed that one of the things we know about a box plot is it divides the data set into 25% pieces. So again, something a lot of you already knew about box plots, but maybe you hadn't realized before. So if you go to any single part of the box plot, it contains 25% of the observations. And the final thing I'll say about the do now is I hope number three felt nice and easy. A lot of our multiple choice have felt challenging, and I would guess that number three felt kind of easy. Number four was maybe kind of hard, but once you looked at the answer, you probably realized how to do it. Isn't that the way probability always is? Yeah, that's probability. Anyway, and again, reminder, if you want to keep track of your scores as we're doing these do nows, once we're done with 10 do nows, you will have a mock score. And you can just keep track of the number you get right out of the 40 questions. A few comments about Super 6 number one, the aircraft problem. Reminder, when you talk about slope and y-intercept, you always have to use the word predicted or expected or about. The y-intercept is what we predict the starting value will be when x equals 0. And the slope is the predicted increase in y for every one increase in x. So don't forget a word like predicted or expected, maybe about or approximately or roughly, although the best word really is predicted or expected if you want to get full credit. Speaking of the word predicted, reminder that a residual is equal to the actual minus the predicted, the y minus y hat, and that spells RAP. And if that sounds like chi-squared, it kind of is. Actual minus predicted is the same idea as observed minus expected, which is on your formula sheet. Observed minus expected squared divided by expected, but it's the same idea. Something that we observe in our data set compared to something that we predict from the model. So hopefully that's helpful. Reminder, a lot of you guys seem to forget how to do part I, which is the correlation coefficient. And the correlation coefficient is just the square root of r squared. So turn r squared into a decimal, which it was 87.4%. Take the square root of r squared, and you get the correlation, 0.934. That is strong, that is linear, and that is positive, SOFA. And don't forget that if the slope is negative, the correlation coefficient will be negative, but that did not apply in this case. Two more observations. You had to look up a t star given n minus 2 degrees of freedom. The t star was 2.365. So make sure you keep looking up the right t star given the degrees of freedom that is appropriate. One of the things the AP test likes to do is it likes to take that standard error that you're given and it tries to trick you by seeing if you want to take that standard error and divide it by the square root of n, which is what you do for a mean, but it is not what you do for a slope. So do not divide that standard error by the square root of n when you're making a confidence interval. And then finally, I hope you're getting used to look at that p-value for slope. I know it's one of the last things we learned. It's the last thing we learned. But the p-value for slope was very small on this regression table, less than alpha, which means we do have evidence for a linear relationship. Yay! All right. So there's a few tips. I hope this is helpful. A few tips for passing your final, a few tips for passing the AP exam. I miss you guys. Hope all is well. Stay happy, stay healthy, stay safe. I will see you soon. Take care.